All right, we're back, and in this video we're going to level up our producer-consumer implementation and put to good use the new tools that we've learned in the last video. All right, back in the IDE, let's jack up our skills with a more complicated producer-consumer problem. And let's say in this case, instead of a simple container, we have a buffer where producers can produce values and consumer can consume values, plural. So we have producer, which produces a value inside one of, say, 3 spots, and the consumer extracts any value which is new inside this buffer. This is more complicated because now we have many values and the producer and the consumer may run indefinitely. So the producer may continue producing values and the consumer may continually consume values. Now the problem here is more complicated because now both the producer and the consumer may block each other. So say for example that the buffer is full. So that is, the producer has produced enough values to fill the buffer. Now, in that case, the producer must block until the consumer has finished extracting some values out of the buffer. And vice versa. If the buffer is empty, that is, if the consumer is too fast, then the consumer must block until the producer produces more. So this is the level 2 of our producer-consumer problem. Let's see how we would approach that. Now, if you want to take a stab at this yourself, this is an incredible exercise and I encourage you to pause the video and try this yourself. Otherwise, continue along with me. So let's do this. Let's say we have a method called prodcons large buffer, right, which will contain all the logic inside. So as before, we are going to instantiate both the producer and the consumer threads within the same method. And in this case, our buffer will be, instead of a simple container, we'll just use an already implemented data structure, a mutable queue. All right, so we need to import the mutable package, Alt-Enter, Scala collection mutable. And let's just instantiate this new mutable queue int. Okay, and we are going to enforce the max capacity of this buffer to, let's say, 3. Okay, we can set the capacity later to whatever value we want. Okay, so this will say that we have a buffer, which in theory can hold as many values as we want, but we will enforce the capacity to be 3. So the producer can produce no more than 3 values without blocking, and the consumer cannot consume more than 3 values without blocking. Now, let's instantiate the little threads. So the consumer thread is going to be a new thread with the following logic inside. Now, keep in mind that both threads in this case will run forever, so they will have some form of a while true. Okay? And we will simulate some sleeping times for both threads by using a random number generator. So we'll just say random equals new random. All right, and we'll just import the Scala util random class. Now, inside the while true, what are we going to do? Well, we are going to synchronize on the buffer because any access on the buffer needs to be synchronized. Otherwise, we would have 2 threads concurrently accessing and modifying this buffer. We don't want that. So we are going to say buffer.synchronized. And inside, we are going to do the following. We are first going to check if the buffer is empty, because if the buffer is empty, then there's no more work that the consumer will need to do, so it will wait on the buffer's monitor. So if the buffer is empty, then I will just print that I'm waiting, so that I log something to the console. So let's say consumer buffer empty waiting. All right, and then I'm just going to call buffer.wait. All right, now after this if clause, there must be at least one value in the buffer. That's either because the buffer is not empty, and remember, I am in a synchronized expression, so the producer is not operating at the same time on buffer. So either buffer is not empty, or it is, and I'm woken up by the producer. So again, the buffer must not be empty. So at this point, I'm free to consume a value. So let's say val x equals buffer.dq. All right, so I'm extracting a value out of the buffer. So I'm free to process it in some way, but I'm just going to be very boring, and I'm just going to print it out. So I'm just going to say consumer, I received or consumed X. And at the end, I need to do something else. What exactly? We'll see in a second. All right, so after this synchronized expression on buffer, then I'm just going to sleep. So thread sleep, let's say random next int, and let's say I sleep 500 milliseconds max. All right, so the consumer in a while true loop, so forever, it will try to extract a value out of the buffer and then simulate some kind of long computation or something very, very important that the consumer needs to do with the extracted value. All right, and then it will go over and over again. Now the producer is also a new thread, and it will do the following. Let's say it also has its own random number generator for sleeping times, and it also has some kind of sequencer so that we keep track of which values are getting produced. And again, in a while true, we are going to do a number of things. So we are still going to say buffer synchronized, because one operation of the producer is going to happen in a synchronized expression on buffer. So this will attempt to insert a new value in the buffer. And the logic here in the producer is going to be pretty similar in the sense that instead of testing if buffer is empty, we're just going to say if buffer is full. So if buffer.size is equal to capacity, that means our buffer is full. All right, and then we'll print that I'm the producer and buffer is full, so waiting. Okay, and then I'm still going to call the wait method, so buffer.wait, and I'm going to wait for the consumer to wake me up. All right, and at this point there must be at least, instead of one value, it's going to be one empty space in the buffer for me to produce a value, either because the buffer size is less than the capacity, or it is, and the consumer has finished extracting a value out, leaving me at least one empty space for me to fill. So I'm just going to say buffer.enqueue, that is my producing logic, and I'm just going to queue the number I, and then I'm going to increment it. All right, so let's say print line, and I'm going to write producer producing and the number I, and then I'm going to enqueue it, and then I need to do something before incrementing I. Of course, after the synchronized expression, the consumer will still sleep its own precious time, so just random next int. Let's also say 500 milliseconds. We are going to play around with these values and see some very interesting effects. But first of all, let's examine our little to-dos here. So after the consumer has finished extracting a value, it needs to do something, and the producer, after producing a value, it needs to do something. If you take a careful look at this little code, we have written both threads to wait, but we haven't written any notifying, which is what we are going to fill back. So in this to-do, I'm going to write buffer.notify. What does that mean? That means that the consumer has finished extracting a value, so in the case that the producer is sleeping, just in case, send a signal. At the same time, the producer, after producing a value, in the case that the consumer is sleeping, notify it. So buffer.notify. So what this basically says is, hey producer, there's empty space available. Are you lazy? All right. Even though the producer might or might not be sleeping, and this guy says, hey consumer, new food for you. Regardless of whether the consumer is actively working or not. All right. So these are just signals. Cool. So at the end, I'm going to call this prodconst large buffer method. So prodconst large buffer. And let's comment out the smart prodconst because we are getting even smarter. And let's right click and run and see how this works. But of course, I forgot to start the threads. So consumer start and producer start. And we should be fine to go. So right click run. And let's see them in action. And as you see, they're running very nicely. And indefinitely. So let's just stop them and analyze some of the output. We already see that the producing logic has already produced 40 values. All right, so let's examine this little piece of output. So producer produces 0, consumer consumes 0 almost instantly. Now the consumer says buffer empty waiting, and once the producer produces a value, the consumer instantly consumes it. If the producer produces a value, the consumer almost always consumes it. And notice this interesting case that the producer produces 2 values and the consumer is late to consume them. And so on and so forth. So we have buffer empty, so buffer full. As you see here, the producer is on average producing more values than the consumer is able to consume. So the producer blocks on buffer full and waiting for the consumer to eat them out. So on average, you see that the producer and consumer are in equilibrium, and that is, they're producing and consuming values at roughly the same speed, and the situations with buffer full and buffer empty occur in a balanced ratio. Now, as I promised, let's play around with these sleeping times and see what happens. So if, for example, the producer is 2 times faster than the consumer, then it should block on buffer full more often than the consumer. And as you see, the buffer full occurs so much more often. So if you take a look at the beginning, there's healthy producing, and the consumer even says buffer empty, but soon enough, the buffer is full, and the consumer, as soon as it extracts some value, the producer is so eager to produce even one more value and then block. And as you see, if the consumer is slower, then the producer-consumer problem will most often block on buffer full. And vice versa. If I change this time back and make the consumer faster, then this should block more often on buffer empty. So if I run this again, as you see, we're producing, but most of the times, the consumer is blocking on buffer empty. All right, so I'm going to stop this. So we see some portions of balanced producing and consuming, but we see the buffer empty situation occurs so much more often now. All right, so this is pretty cool. We've managed to create a multi-threaded application in which 2 threads that are doing different things operate in harmony. This is very, very nice. But we're not done. We want to be rock stars. So in the next video, we're going to enhance this for multiple producers and multiple consumers on the same buffer.